Welcome to Lesson 1.4 of Consumer Math, Operations with Integers. So this might look a little scary, the word integer, if you're not used to it. An integer is just a number. It's just a fancy way of saying number, and it includes all of the positive whole numbers and all of the negative whole numbers and the number 0. So that is what integers are considered. So let's look a little bit more at operations with integers. So I wanted to review our vocabulary from this part of the chapter. So we've already discussed what integers are, and they are all the negative numbers, and that's what this little ... or this ellipse means. It means it goes on and on forever in this direction. So any negative number that you could think of, no matter how big, you can always add another negative number to it and increase it. So it goes on and on forever in that direction, and then you have a 0, and then you have all the positive numbers 1, 2, 3, 4, 5, 6, 7, on and on and on forever into the other direction. So the biggest positive number that you could think of, you could still add 1 to it and make it bigger. So there is no end to the number of negative numbers, and there's no end to the number of positive numbers. And all of those together, that entire group, we just refer to them as integers. So opposite numbers are, the definition says, a and negative a such that a plus negative a is equal to 0. And that just simply means that a is going to be the same symbol. So that means if I had 2 and negative 2, if I were to add those together, that would be 0. That's the same thing as saying 2 minus 2 is 0, which we know is true. So that is what it's talking about, a number and its opposite. And an opposite doesn't have to be the negative number. You could start with a negative 2, and then the opposite of negative 2 would be a positive 2, because this times negative 1, whatever the number is, you multiply it times negative 1 to get its opposite. And we know that when we multiply a negative times a negative, we get a positive number. That would still equal 0. So that is the opposite. To find the opposite of a number, you're going to multiply by negative 1. That's how you're going to find the opposite of any number. Now the absolute value, I'm going to erase this. The absolute value is going to be the distance from 0 on the number line. So to get an illustration of this, I need to draw a picture of a number line for you. Let me do that. So here I have an illustration of the number line. So absolute value is the distance from 0. That's the part that is important. Since distance can never be negative, think about if you were to measure something, it's never negative. It's always a positive number. Absolute value is always a positive number as well. So let me illustrate that for you. Let's say I had the absolute value of negative 3. Okay, negative 3 is here. So the distance away that it is from 0 is 1, 2, 3 spaces from 0. So that is 1, 2, 3. That's a positive 3. It's 3 spaces. So the absolute value of negative 3 is positive 3. Well, what about the absolute value of positive 3? How would we do that? I'm going to use a different color for that. So if I'm looking at positive 3, the distance from 0 is 1, 2, 3 spaces. So the absolute value of positive 3 is also a positive 3. So it's all about how many spaces away on the number line it is from the origin, which is 0. So that's all you have to do to find the absolute value. If there's only a single number within the absolute value brackets, that's what these are. These are symbols of inclusion that ask you to find the absolute value or the distance from 0. If there's only one number, then you just change it to a positive. That is your answer. Sometimes you're going to see situations where you have operations like 11 minus 2 is equal to what? So what you have to do here is find the calculation inside first. We treat it just like we would treat parentheses. So 11 minus 2, that would be 9. So the absolute value of 9 would be 9. So that is how you would find anything that's within the bracket, you go ahead and do that calculation first, and then you take the positive value of whatever's in here. What about if we had 2 minus 11? What would that be? Well, 2 minus 11 would be -9. The absolute value of -9 is going to be a +9 because it is 9 spaces from 0 on the number line. So whatever your final result is within these absolute brackets, or the absolute value brackets, you just make it the positive form of that, and that is going to be your answer. All right, so let's move on. Now, if I'm ever going too fast for you and you want to write this down, all you have to do is pause the video, write it down, and then press play to move forward. So it's always the positive number, and I'm going to add to this that, if I can spell, sometimes Miss Tracy's good at math but not good at spelling. It's always a positive number that is the result inside the absolute value brackets. So whatever's inside of here, this X, whatever it might be, this just stands for an unknown value, it's equal to the positive value of that. Okay, subtraction is adding a negative number. So let me explain that to you. When we have positive and negative numbers, we think about integers. We're actually, when we're subtracting, we're actually just combining positive and negative values. So if I were to say 2 minus 2 is 0, which we know is true from our elementary math, what we're actually doing is we are saying 2 plus -2 is equal to 0. So again, on the number line, let me show you how that works. So on the number line here, I have an example, and we're going to start with the +2. Any integer that does not have the positive sign in front of it, or it does not have any sign in front of it, is considered positive. We only illustrate the negative numbers because we assume a number is positive if it doesn't have a sign. So it has a negative sign in front of it, it's a negative number. Otherwise, it's a positive number. So we started with a +2 here. We're at the 2. Now, negative on the number line means to go to the left, and positive means to go to the right. So we're going to go back to the left 2 spaces. So that means we would go 1, 2, this direction. So starting at the +2, we moved to the negative side of the number line 2 spaces, which takes us to 0, which is our answer here. So this is another way for you to see how subtraction is just adding negative numbers. We added going backwards to our thought process. We added going backwards here. Now, if this had been a +2, let's do +2, it would look like that. And I'm going to use the blue. So this would not be true, right? It would be 2 plus 2. We know that would be 4. How do we know that's 4? Well, if we started at +2 and then we added 2 positive steps to the positive side of the number line, we would end on the 4. So that is why 2 plus 2 is 4. It's because of the way the number line works. This is actually what you're doing when you subtract. You're subtracting, but subtracting is just adding a negative number. So what that does is it allows us to rewrite problems to where they make sense, to where we can see them. So if I said -7 minus 2, that could be confusing. So instead what we're doing is we are saying -7 plus -2. That makes it much clearer that the signs are the same and we're just adding the values together. So our answer would be -9. It's easier to see that. And there are some rules about adding negatives and positives that we're going to go over in the next couple lessons. But for now, just know that whenever you're subtracting, you're actually adding a negative number. And especially when you start with a negative number, it can help you do the math a little bit easier in your head by just changing it to where you can see what's going on. Okay, so that is what I mean when I say subtraction is adding a negative number. So let's move on to the first example problem. Our first example says to give the absolute values of -7 and 5. So we would write it like this: -7 is equal to, and the absolute value of +5 is equal to. Well, remember, all we have to do to find the absolute value is take the positive value of whatever is within the brackets. So that would be a +7, and the absolute value of +5 would be +5. Easy peasy. It's pretty straightforward. It's a very easy thing to calculate. Let's look at the next example problem. Example 2 asks us to add the integers. So we can see it's already given to us in the addition of negative numbers. So a -6 and a -2 added together would be a -8. A +9 and a +4 added together would be a +13. A -4 and a +7. Well, whenever you have a negative in front and a positive behind, you can rearrange that to look like this if it helps you think about it better. And the answer to 7 minus 4 would be 3. Whenever we have this situation, we can rewrite it again, 5 minus 9, so that we can think about what's going on. Well, on the number line, if we were to move backwards 5 places, we'd be at 0. Well, then we'd have to go another 4 places because we're supposed to move 9 total. So that'd be a -4. So the answer to 5 minus 9 is -4. And there are some rules that we can think about. Whenever you have two signs that are the same, right here, you add them together and you keep the sign. So these are both positive numbers. So 9 and 4 are 13, and because they're both positive, this is a +13. When you have negative numbers that you're adding together, which also looks like this, by the way, when you have the same sign, you add them together, you keep the sign. That's rule number 1. Same sign, add together, and keep the sign. Now, when you have different signs, as in this situation, what you're going to do is you are going to subtract the smaller from the larger, keep the sign of the larger number. So in this case, when we did 5 minus 9, what we actually did was we said 9 minus 5, and we knew the answer was going to have to be a negative because the larger number is a negative number. So 9 minus 5 is 4, but we made that a -4 because the 9 is negative and it's the bigger number. So those are your two rules for adding integers. If you have the same sign, add them together, keep the sign. If you have two different signs, subtract the smaller from the larger, keep the sign of the larger, which is exactly what we did in this problem. 7 was larger. We subtracted the 4 because it was a negative and this was a positive. And 7 is the larger number, so the answer is going to have a positive number or a positive sign. So that would be a +3 here. So those are your rules for adding integers. We're going to want to write those down and keep that information handy. Let's do the next problem. So here we have another set of problems, and this is to subtract the integers by applying the definition of subtraction and the appropriate rule for addition. So we have -5, and if we think about it, this is a -7. So this is -5 plus a -7, right? The signs are the same. So we add the numbers together and keep the sign. So that is going to be a -12. Here we have a positive minus a negative. So that's actually 2 plus -1 times -10. So when we have a negative times a negative, that becomes a positive number. So this becomes 2 plus 10. So the answer here is going to be 12. We have a similar problem here. We have -6 plus -1 times -5. Whenever you have a minus sign outside of parentheses, it is a -1 being multiplied times whatever is in the parentheses. So if you just insert that 1 right there, it will remind you to do that, or you can rewrite it like this. So a -1 times a -5, this can be a -6, and this becomes a +5. So we have different signs here. So we're going to subtract 5 from 6, which would be 1, and 6 is the larger number, so it's going to be a -1 is your answer. Now we have 3 minus 7. So this is going to be a +3 plus a -7. Well, in this case, 7 is the bigger number. So 7 minus 3 is 4. But because 7 is the bigger number and it's negative, the answer is going to be a -4. Our next example problem is about multiplying integers. So you have to remember the rules for multiplying positives and negatives. So the rule is that when the signs are the same, the answer is positive. When the signs are different, the answer is negative. So 8 times 2, both of these are positive, so it's going to be a +16. Both of these are negative. 3 times 7 is 21. Negative times negative makes a positive, so the answer is a +21. Here we have a negative and a positive. So when the signs are different, the answer is negative. -5 times +4 is going to be a -20. And the same thing here. We have negative values. So 6 times -9 is going to give you a negative answer because the signs are different, and that answer is -54. Next problem. Actually, let's write that down. First, when multiplying, when signs are the same, that equals a positive. When signs are different, that equals a negative. So remember those two things. You're going to want to take that down in your notes to remember if you don't already know that. Let's look at the next problem. In example 5, we're asked to divide the integers. So one of the rules for dividing integers, it's the same as for multiplying integers. So those are, first of all, when the signs are the same, the answer is positive. And when the signs are different, the answer is negative. And that it is true for both multiplication and division. So here we have two positive integers. 36 divided by 9. If you know your multiplication tables, you know that that is 4. So the other way to write this would be as a fraction, 36 divided by 9. So if you ever see it like this, it's the same thing as this. Here we have two negative numbers. And sometimes I find that it helps to write it as a fraction so you can see it a little bit better. Negative 28 divided by negative 4. Now it's obvious your signs are on top of each other and you can see them a little bit better. It's easier to keep straight. Negative 24 divided by 4. You can ignore, when you have a negative by a negative, you can actually just ignore the negative signs and just do the math. So 28 divided by 4 would be 7, because we know that would be a positive answer anyway. Here we have a negative 50 divided by 5. The signs are different, so our answer is going to be negative. Once you figure out whether the sign is positive or negative, you can ignore the signs and just divide the numbers. 50 divided by 5, that's going to be 10. Here we have 14 divided by a negative 2. It's a positive and negative, so the answer is going to be negative because they're different signs. So now we can ignore the signs and just do the math. 14 divided by 2 is 7. So that's one way to do it, is to look at your signs first and decide if your answer is going to be positive or negative before you do the math. Then once you figure out the sign, you can ignore the rest of it and just do the mathematics here and pretend they're positive numbers and add it to your answer. So that is a strategy that could help you to keep it straight. Figure them out like they're two separate problems. So let's talk about order of operations for just a minute. If I could actually spell it, that'd be great. So order of operations. So here is the order. The first thing you want to do is address any symbols of inclusion. And the most common symbol of inclusion is parenthesis. But you also have brackets, square brackets, curly brackets, absolute value brackets. So you have a number of symbols of inclusion, and there you have parenthesis, you have curly brackets, you have square brackets, you have absolute value brackets, and another symbol of inclusion that we're going to talk about later is the fraction line as a symbol of inclusion. That is something that you have to think about as well. So we always do whatever is inside these symbols of inclusion first. And most of the time when you have multiple symbols of inclusion around each other, you're going to go to the innermost symbol of inclusion. So you might have something that looks like, here's a curly bracket, and then here is some number, and then you have a square bracket, and then you might have some parentheses that are added together inside, and then all of that is multiplied by some other number out here. We'll call this A. We'll say this is B plus C, and then D minus E, and these are all different values. So you would do B plus C and D minus E first, because this is telling you to do that within these parentheses first. You go to the innermost inclusion set, and that's these. Once you get the value for B plus C and D minus E, then you look, and the next symbol of inclusion is to do this calculation inside of the bracket. So you do that calculation inside of the bracket, and then you get a single number result there. Then it asks you to multiply. You have this little set of brackets, so you move to it and you multiply whatever that value was that you came up in here. Then when that's over, you have a number out here that you're multiplying, so you multiply whatever all of this equaled. So it's like a road map. It tells you where to start and where to go next and how to finish. Now within those symbols of inclusion, and once you have finished the symbols of inclusion, then you have a series of things that you do. And the first thing that we do underneath the symbols of inclusion and after the symbols of inclusion, that's going to be exponents. So you do any exponents that you have first. Now with exponents, it also includes radicals, or what we call roots, if Miss Tracy's pen will cooperate with her. So exponents and roots, you do that first. Now an exponent is when we say 2 to the second power, or a root would be 16, the square root of 16. So this would be 4 and this would be 4, right? So you would resolve those into whole numbers as much as possible first. Then move on. After that, you're going to do multiplication and then division. In the order they occur from left to right. So that does not mean do all the multiplication first and then do all the division. It just means do them together in the order you see them. So if I have a problem that says 3, actually let me start with a bigger number. If I have a number that a problem that says 9 divided by 3 times 2, I would not do this first. Multiplication and division are on the same level. So I would say 9 divided by 3 is 3, and then 3 times 2 would equal 6. So that would be my answer. If you did this first, you would get a completely wrong answer. So we do it in a certain order every single time for the sake of everybody having the same result. And that would be left to right, multiplication and division in order as you see them. Then we have addition and subtraction. And because we know that subtraction is just the addition of negative numbers, we know that that's really the same step, right? So there is no doing addition first and then doing subtraction second. Instead, when we see a problem like this, 4 plus 2 minus 3, we know that this is 4 plus 2 plus a negative 3. So it's all addition anyway. We just combine positive and negative integers together to get a final result. So when you think about addition and subtraction, think of it like that, and it will help you to see it as you move from left to right. It doesn't matter the order that you actually add it in. What matters is keeping the sign with the integer so that it can be properly applied. Okay. All right, so that is your order of operations. And one of the things that we do to remember the order is we give it an acronym, and that acronym is PEMDAS. And PEMDAS stands for parenthesis, which is our way of doing symbols inclusion first, then exponents, which reminds us to do exponents and roots, and then multiplication and division, then addition and subtraction. So it's kind of like this. You should see it like that in your head, because these two go together and these two go together. So PEMDAS reminds us of what order to do everything. All right, so let's look at example 3 now that we've discussed order of operations. So let's apply PEMDAS to this example problem. So first of all, PEMDAS, let's write it up here, PEMDAS. So let's look for parentheses first. We have parentheses, but they only have a value inside of them. So we really don't need to do anything inside the parentheses. So we can skip the parentheses part and move on to exponents. I don't see any exponents. I don't see any roots, so we can skip that part. I do see some multiplication and division. So this little dot right here, in algebra and other math, we use a dot sometimes as well as parentheses to represent multiplication, simply because if we use the letter, or if we use the x and then there's the variable x, and we'll talk about variables later, if we use that variable x somewhere else in the problem, excuse me, it can get confusing. So instead we use the dot because we don't use that for anything else. So this means to multiply. So let's do the math, multiplication and division, in the order from left to right that it occurs and simplify this problem. So the first thing I see is this division of 8 divided by negative 2. So if I write that over here like a fraction, it would help if I wrote the right number. 8 divided by negative 2 would be negative 4, right? Let me move this over. Oops. I moved it over too much, didn't I? Okay, so let me erase it and write it over here out of the way. So 8 divided by -2 would equal -4. So I can get rid of this and put -4. Or I can just rewrite it. 4 plus -4 times -5. My dot's in a different spot. Minus 3. That's my new problem. If you will do each step and rewrite it, it will help you to see what's left. So now I have multiplication. So I have a negative number times a negative number. So -4 times -5, a negative times a negative, that's a positive, and 4 times 5 is 20. So it's a positive 20 for those two operations. So 4, a positive and a positive, that's the same sign. So it's plus 20 minus 3. All right, so that's multiplication and division done. Now I have addition and subtraction, which we know is just the addition of negative numbers, right? So you just do it in order from left to right. So 4 plus 20, that's 24. And we have a negative and a positive number. So we're going to subtract the smaller number. And because the larger number is positive, we'll keep the positive sign. So 24 minus 3 is 21. And because 24 is bigger, it's a positive 21. So that is our answer, positive 21. So that's what you need to do as you work these. Take the first two operations of the first group of multiplication and division, the first two in order from left to right. Perform that operation. Rewrite the problem. And when you rewrite the problem, substitute that answer for those two terms. Then you take the next two, rewrite the problem. Then you go on to your addition and subtraction once you get everything for multiplication and division done and all you have left is addition and subtraction. Then you can rewrite the problem as you need to as you combine steps. It helps to keep the information straight and so that you don't have to hold it all in your head. That's why God invented pencil and paper, so we can write stuff down. So write it down. It makes it easier. You don't have to keep it in your brain. You don't have to do all this mental math because, I mean, that's what we're going to do. When we solve a problem in the real world, we're not going to do it in our head. We're going to use a calculator. We're going to use a piece of paper and a pencil. So use your tools that God has provided. All right, so the answer here is 21. So let's move on to our last example problem, example 7. So here we have another problem with multiple operations in it. So I'm going to rewrite my PEMDAS just to remind me of what I need to do in the order that I need to do it. Then the commas help me to remember what goes in what order and what goes together. So I'm looking for parentheses and I see some operations in parentheses. So here I have an operation within parentheses that says 12 plus 3. 12 plus 3 is 15. So now I replace this with 15. And I can get rid of my parentheses because there are no numbers on the outside that tell me to multiply. Instead, my next operation is division. So I'm going to divide, but I'm not going to divide yet because I have some more parentheses here. Some more symbols of inclusion. So here I have this little square bracket. If you notice that, that is including or has parentheses on the inside. And that parenthesis on the inside is telling me that I need to multiply -2 times 3. Whenever we multiply whatever's on the outside of a parenthesis, we have to take the sign that is with the number. Because what we know about this is that it's actually 9 plus -2 times 3, and that's what it's actually doing. So you're going to take the sign that is in front of the number whenever you multiply. So -2 times 3 becomes -6. So this is now 9 plus -6. So whenever we have we can just rewrite that actually. Let's just go ahead and write that step. So that would be 9 plus -6. And then we have another parenthesis, -4 there. All right, so now that it's simplified, oh, and I forgot my back. Right, there we go. So now that it's simplified, I can think about this the way that I need to. I have different signs, a positive and a negative. So when you have different signs, you subtract the smaller from the larger and keep the sign of the larger. So 9 minus 6 is 3, and the sign of the larger number is 9, so it's a positive 3. So now I can rewrite this as 15 divided by 3, and then this parenthesis negative 4. When you have brackets and parentheses, or parentheses and parentheses, when you have symbols of inclusion that are next to each other, that's another way of writing multiplication, just like it was here. So we're going to multiply 3 times negative 4. So that's going to be negative 12, because it's a positive and a negative, so the answer is negative, and 3 times 4 is 12, so negative 12. So 15 divided by negative 12 is our problem. And we can rewrite that if we want to as a fraction, just to show us, we can see our signs a little bit better that way. They don't get all confused with all these other symbols. So it's going to be a negative number. And that negative number, it's going to be actually, you know what I did? I did that wrong. Miss Tracy did that wrong. I am so sorry. Because you know what I did? I said 15 divided by 3 and then negative 4. I multiplied that first. I should not have done that. So I was on such a roll with this that I forgot about my rules. And my rules say multiplication and division are the same. So I had to back up. 15 divided by 3 is 5 times negative 4. 5 times negative 4, different signs, it's going to be a negative answer. 5 times 4 is 20. So that is what I should have done, and I am so sorry. It is easy to make a mistake here. It's easy to make a mistake. So every time you write your next, that's one of the reasons why you want to write your next steps out once you simplify from one set to the next, or one symbol of inclusion to the next symbol of inclusion. That's why you want to write it out, because then guess what? It's easier to see. And it's easier to see your mistake when you make one. And it's okay to make a mistake. It's perfectly okay to make a mistake, because when we make mistakes, we learn from them. We learn what to not to do the next time. So when you make a mistake, just go back and redo it. And say something's not right here. It wouldn't have ended up right. That would have been 15 divided by negative 12, which is not going to be a whole number. It's going to be a fraction of some kind. And that is not, that wasn't the answer we were looking for. That wasn't how it was supposed to be. So the fact that my answer was weird looking is the clue that I needed to go back and look at what I did again. So whenever your answer is weird looking, go back, look at your steps. What did you do something out of order? What did you get your negative signs, your positive signs mixed up? Those are some clues to help you out. Now, that being said, sometimes your answer is just going to be weird looking. But if it is, just go back and look, make sure you did everything right. And then if you did make a mistake, you can correct it. If you didn't, you just have a weird looking answer. Sometimes that is what it is. And that is the last example problem that we have for lesson 1.4. So I will see you in lesson 1.5.